Hello everyone, my name is Raina DeJute and welcome to week 2 of a 2-week collaboration project for code blogs. So a bit of context before we jump in. In week 1, I built the front end and my partner built the back end, and then in week 2 we swapped. So this week I was working on the back end that my partner has originally set up. That means that my job wasn't to build the back end from scratch, it was to come in, understand an existing code base, and implement some specific features that were either missing or incomplete. And honestly, I think it's been a really valuable experience because in a real job, I'm going to spend a lot of time working inside code that someone else wrote. So the process of breaking it down, auditing the existing code, and understanding patterns and structures was really good practice for me. So in this video, I'm going to walk through the backend at a high level so you can see what I'm working with, and then I'll go deeper into specific things that I actually built. Cascade delete, authorization middleware, admin middleware, and an auth utility file. So let's get into it. Okay, so first things first, what does the backend actually do? So Code Blogs is a social blogging platform. Users can register, log in, write posts, comment on posts, and like them. And then there's also an admin system that lets certain users manage content and other accounts. The backend in this project is a Node.js and Express API. It uses MongoDB as the database, Mongoose as the ODM to define schemas and interact with data. Passwords are hashed with bcrypt, and authentication is handled through database-backed sessions, not JWTs, which I'll explain a little bit more in a moment. And the codebase is organized in an MVC structure, which stands for modal, view, and controller. In this specific setup, the backend only contains API logic, so there is no view folder. So in this setup, we only actually have models, routes, and controllers. So our models define the data schema. So we've got our comment schema, which defines exactly what the API expects and in which format. We have our routes that define API endpoints and hookup middleware. And then we have our controllers, which handle the actual request logic, like validating input, talking to the database, and sending back a response. And then we've got our middleware. So our middleware acts as the gatekeeper on certain routes. The require auth is to protect all authorized pages, and the require admin is to protect specifically the admin pages. So this is the structure that my partner kind of put into place, and it gave me a solid foundation to work within. My contributions this week were focused on specific targeted pieces, not rebuilding the whole thing. So before I get into my contributions, let's walk through how a typical request flows through the system, just to be clear on how everything connects. Say a logged in user wants to create a post. So here's how it happens. Step 1 is the React front end sends a post request to API posts, and it includes a section cookie in the request. And then step 2, in our server.js, our Express server receives that request from the front end, and it runs it through global middleware. So first it runs through cores to allow the request, then JSON parsing so the request body is readable, then cookie parsing so the session cookie is accessible, and then this request hits the post router, which is defined here. And if we flip to our post route really quickly, we can see that to create a post, it requires authentication. So before the controller runs, the auth middleware fires. So if we take a look at the auth middleware super quickly, this middleware reads the session token out of the cookie using the auth util file, which is right here. Then this await session find one looks up the session in the MongoDB database, checks that the session hasn't expired, and if everything looks good, then it attaches the user information to the request object. Then the controller runs. So in our post controller, it reads the requested user ID to get the authentication user's ID, grabs the content from the request body, saves a new post document to MongoDB, and then it sends back a JSON response. As we can see, we either get a status OK or we get an error. That's the basic pattern for pretty much every protected route in this system. So my job was to make sure that those protection mechanisms like auth checks and admin checks actually worked properly. All right, and onto the main part, let me walk through the 4 things that I actually built this week in the backend, starting with our auth util right here. I want to start here because this is the foundation that everything else depends on. So authutil.js is a small utility file that lives in this utils folder. Its job is to extract the session token out from an incoming request. And the reason this needs to be its own function is that the token can come from 2 different places. If the request is coming from the browser, the token arrives as a cookie called session_token. But if the request is coming from something like an API client or a mobile app, it might arrive as a bearer token in the authorization header instead. So the extract session token function checks both places. First, it looks at requested cookies session token. That's the cookie. If nothing's there, it checks the authorization header and pulls out the token that comes after the word bearer. The reason this matters is without centralizing this logic, every single middleware or controller that needed the token would have to duplicate this check. Putting it in a utility function means the middleware can just call this extract session token that's defined at the top and get back whatever token is available regardless of where it came from. It's a small piece, but it's the kind of thing that makes the rest of the authorization system cleaner and easier to maintain. Next, I implemented this require auth middleware. This is what protects majority of the routes in the system, and here's the problem it solves. Most of the API endpoints, like viewing posts, creating comments, liking something, should only be available to logged in users. Without this middleware, anyone can just hit those points directly. So require auth runs before the controller on any protected route. So first, it extracts the session token to get token from the request. If there's no token at all, it'll send back this 401 response and a message saying that the session is invalid or expired. If there is a token, it queries the database for a matching session document and populates the associated user, and we can see that here in this session find one. If no session is found, or if the user attached to that session doesn't exist, it returns another 401 response. Then it checks if the session has expired, so sessions are valid for only 24 hours. If the session is past its expiration date, then the middleware deletes that session from the database and returns a 401 with an expired session message. If everything checks out, token exists, session is valid, session is fresh, it attaches the session and user data to the request object as request session right here and request user, and attaches it with the new session token. Then it calls next, which passes it to the controller. From that point on, the controller can trust the requested user completely because it knows exactly who is making the request and it doesn't have to do any session checking on its own. The next piece of middleware that I implemented is this require admin. This middleware builds on top of require auth, so it's always used after a require auth on routes that should be only accessible to admin users. The way user roles work in the system is every user document has an auth level field that's either basic or admin. That's set when the user is created, and the default is always basic. Require admin does one simple but important check. It looks at the requested user's auth level. If it's not admin, it returns a 403 response and a message saying admin access is required, and the request doesn't go any further. The middleware is what gates the admin-only endpoints, updating or deleting a user account, updating or deleting a post, updating or deleting a comment. Without it, any logged-in user can make those changes, which obviously we don't want. The reason it's separate from require auth is that not every protected route needs admin access. Rather, regular authenticated users can create posts and comments freely, they just can't delete other people's comments or manage other people's accounts. By keeping these as two separate middleware functions, the routes can mix and match as needed. And you can see this in some of the route files. Some routes chain just require auth, and some routes chain require auth and require admin together. The intent is right there in the route definition, which makes it easy to audit. And then moving on to the last and most involved piece that I worked on is the cascade delete functionality. This shows up in two places, when a post is deleted and when a user is deleted. So let's explain why this matters. The data in this system is relational even though it's in MongoDB. So a post can have many comments, a user can have many posts. Those comments and posts are stored as separate documents in separate collections, but they reference each other by ID. If you delete just a post directly without handling the comments, those comment documents are still sitting in the database referencing a post that no longer exists. It's called a dangling reference, orphan data that can cause bugs or unexpected behavior and just kind of looks wonky. Cascade delete solves this by cleaning up related documents automatically when a parent record is deleted. So for post deletion, which can be seen right here in the post controller, when an admin deletes a post, first it validates the post ID. If it's invalid, it'll return a 400 saying invalid post ID format. If it's valid, then it queries for all of the comments where the post ID matches the deleted post. It deletes all of those comments and then it deletes the post itself. So by the time the response comes back, both the post and all of its comments are gone. For user deletion, it's a little bit more complicated. So when an admin deletes a user account, the controller first finds all of the posts that were authored by that user. For each of those posts, it deletes the associated comments. Then it deletes the user's post, and finally it deletes the user's account itself. I also added a little extra feature where it also searches all the other posts for a comment that was made by the user that we're going to delete, so that way there's no orphan data anywhere across the whole system. This means a single single admin action cleanly removes the user and all of their content from the system. And the reason it has to go in that order is because if I deleted the user first, then we have comments and posts that exist by this user that haven't been deleted yet and are still existing on the system with no author. The relationship here is that we find the user, then we find all of their posts, then we find all of their comments. Then we want to delete the comments first because the comments are the children of the post. So we don't want to delete the parent, we want to delete the child and then the parent. Comments are deleted, then we move to post. We don't want to delete the user before the post because the user is the parent of the post, which is the child. So then we delete the post, then we delete the user, and then by the time we delete the user, all of that user's content has been erased. So stepping back, let's talk about how these pieces connect to the larger system. So the backend that my partner built had a solid foundation, the modals, the routes, and the controllers, and the basic server setup. But there were a few gaps that my contribution specifically addressed. Before require auth middleware was in place, there was no real enforcement layer between the client and the controllers. When I built the front end, I added in extra guards to make sure that admin pages could only be accessed by admin, but the front end is not there for security. The back end should be the main security enforcement layer. So once I got this backend, that was one of the first things I did, was do that require auth middleware. And now every protected route has a reliable mechanism that verifies identity before any business logic runs. And in the event that those checks somehow fail, the front end also has fallbacks that will still protect these routes. Before require admin, there was no distinction between what a regular user could do and what an admin could do at the request level. Now that's enforced in the routing layer itself. It's visible, it's consistent, and it's something individual controllers have to handle themselves. And the auth utils function, it might seem small, but it means the token extraction logic lives in one place. So if that logic ever needs to change, say the app adds support for a new token format, or we switch from HTTP only cookies to JWT tokens, we only have to change one file instead of changing one piece in all of our files. And cascade delete directly improves data integrity. Without it, the database would accumulate orphaned records over time, which would cause inconsistencies in what the front end shows. What I found interesting working on this is how these pieces all depend on each other. Require admin depends on require auth having run first, require auth depends on extract session token running correctly, and the middleware chain is a linear sequence, and each piece has to hold up its end for the whole thing to work. Coming into someone else's code base and adding to it without breaking it, that requires detailed understanding of how all the pieces fit together, not just writing code that works in isolation. That's what I was focused on this week. So to wrap up, this week I worked on the backend half of the code blogs project. I didn't build it from the ground up. I stepped into an existing system and implemented 4 specific contributions. The auth utils token extraction helper, require auth session validation middleware, the require admin role check middleware, and cascade delete for both posts and users. I think I came out of this week with a better understanding of specifically how a backend works, how middleware chains work, how authentication flows through a backend system, and what it actually means to think about data integrity in terms of deletion. Not just whether it works, but what happens over time and how that can affect the user experience. So, thank you for watching. That's all I got for this video, and I will see you on the next one.